Hello, everyone. Good morning. My name is Devin Burnett. I'm a lead SRE at Betterment. And today, I'm going to be talking about shell access because we've been conditioned to believe that it's just not possible to have a satisfying security posture around granting product engineering teams the ability to handle their own production needs. Not anymore. In this session, I'll be talking a little bit about what we do at Betterment, what we decided to build, what problems we ran into along the way, and some learnings that we took from everything. So what is Betterment? From the outside, Betterment is an investment platform, financial advisor, and broker-dealer based in New York City with over $17 billion in assets under management. But on the inside, Betterment is a company made up of 270 employees, multiple cities. 36% of those employees are engineers writing code in 300 different repositories. These repositories make up a collection of many applications owned by disparate teams across the org, providing functionality for our customers. This means there's a lot of infrastructure and many deploy pipelines configured to keep everything running smoothly. And as we continue to grow, we started thinking about what an ideal situation might look like for a mature organization. At a place with many engineering teams, but only one SRE team, it was important for us to be able to allow the teams to be the custodians of getting their apps to production. We don't want to be the bottleneck anymore. So what did we build? We decided to build a platform as a service that allows our engineers to more efficiently build, test, and deploy their applications with very little involvement from SRE. We wanted a platform that was config-driven, opinionated, works with 12-factor apps. We also wanted this platform to be highly available, built to scale, and all the infrastructure to be defined as code. Amazon came out with EKS, their managed Kubernetes service, at some point early last year, and we were excited about that news because we believe that Kubernetes was a great platform for building platforms. So we began our Kubernetes journey. There's two major components to our platform. One we call Coach, and the other we call Rudder. Now, Coach has a command line client that has the ability to generate config files for our CI pipelines. It also has a server-side portion that is responsible for triggering and tracking deployment events. And then Rudder is essentially a wrapper around Terraform and Helm, where we have a set of shared chart templates for our various types of application runtimes. This is the input for Coach and Rudder, a simplified YAML config file where engineers can detail information about their runtime, database, and workloads. This config file results in an entire CI and CD pipeline being created automatically and ultimately creating Kubernetes resources and other AWS resources. But this is only part of the whole equation. Getting things deployed onto this platform is one thing, but handling operations needs was another obstacle altogether. Our engineers would ask questions like, how do I get SSH access to my thing? And every SRE in here is like, what on earth do you need SSH access for? And then another engineer asks, providing more context, what if I just need a Rails console? So at that point, we realized what folks really wanted, which was different than what they were asking for. Most of our applications are Rails apps or Spring Boot apps that have a console mode that engineers can use to interact with their apps from the command line. So they just wanted console access for their apps for the purposes of running convenience methods and one-off tasks like backfilling a database table. And we were like, oh, but that's not what you said. So I began my investigation where any good engineer does. But after searching really hard and getting sidetracked by the many distractions, I came up with nothing. And so I decided to take the slack. I thought I was sure to find someone that has solved this very same problem before in a community of 68,000 people. So I asked my question, and I gave the scenario, and I had mixed feelings about some of the advice that I received. This one person responded with some of the best practices that they implement at their company. Authorization via RBAC, yes, definitely agree. kubectl exec, yeah, okay, but probably not directly. I'm not sure that we want our engineers to have to know how to use kubectl. And then the buddy system. I'm not a fan. While I'm sure this works for some, I was certain that we could do better if we took what we liked about it and then made some goals for ourselves. So these are the goals that we came up with. We wanted a solution that was isolated, automated and easy to use, minimally privileged, and audited. So what are some of the problems we ran into along the way while trying to meet these goals? Well, one of the main problems with kubectl exec by itself is that you can only connect to an existing container. I think we can all agree that having engineers execing into live production containers is a scary thought. We really want to avoid situations where we have to rely on the buddy system if we can help it. So what we wanted was a brand new pod to be provisioned that's separate from its deployment so that new deploys don't interrupt any currently running tasks. And we also wanted that pod to not be capable of handling any production traffic. Complete isolation. We iterated on a couple of solutions, and we settled on an approach where we deploy a slightly modified clone of our app deployment, but with replicas set to 0. This essentially serves as our mold for creating new isolated pods that have all the config and all the metadata that they need to function properly, such as environment variables, volume mounts, etc. From this dormant deployment, we're able to just copy the pod template off of the deployment to generate our new pods. And so we wanted to abstract away as much as possible for our developers. In most cases, we didn't even want them to even realize the existence of kubectl. So we wanted a solution that was developer-centric and built with tooling that felt familiar to our engineers. So we wrote a CLI command in Coach, where engineers can create isolated pods on the fly, knowing nothing more than just the name of their app and the ecosystem or namespace that it lives in. This CLI command is the entry point to having a new isolated Kubernetes pod provisioned. So in this developer-driven service, we wanted engineers to be able to create pods, but we didn't actually want to give them the permissions to create pods arbitrarily. So from an authentication perspective, luckily we use Okta as our identity provider. And AWS supports role assumption via SAML, so we can scope down AWS account permissions by relying on carefully crafted IAM roles. And then from an authorization perspective, Kubernetes Are Back is tricky, but if set up correctly, we get the necessary level of permissions to have a pod created from an existing deployment and only allow exec permissions to that specific pod. And with these two things working together, we were able to get the minimally privileged setup that we were looking for. So Kubernetes Are Back lets you restrict certain requests to certain resources. So here, you can see we dynamically inject the created pod name to make sure that that's the only resource that the engineer can exec into. kubectl auth has a handy subcommand called can_I. You can pass it a verb and a resource, and it will say, yes, you're allowed to do that thing, or no, you're not. And that was a really big help in putting together the RBAC policies for this. Auditing. If you give humans any access to anything, there should be a way of tracking what they did. So with EKS, we now get all the control plane logs, including the audit logs, that show every API call made to Kubernetes. And then knowing who has access to what is not enough if you don't know what they did with the access that they have. And due to the heavily regulated nature of our products and services that we offer, it's imperative that we know everything an engineer does on a given instance. So for that, we use a product by StrongDM that allows us to capture details about an engineer's session down to the keystroke. The interface looks something like this. You can search for specific activities, queries, and you can even replay a session back and see everything an engineer did during that session. So what does all this look like? The Coach CLI command triggers both the create and exec flows that you see here. So putting all the pieces together, starting at the bottom with the create flow, a user obtains access to invoke a Lambda via Octa by assuming a role with SAML. Once that user has invoked the Lambda itself, authorized with an RBAC cluster role, copies the pod template from the dormant deployment that we saw earlier with replica 0, and it creates a new isolated pod from production traffic. When that pod is ready, the Lambda also creates an R back role scoped only to that pod, like we saw earlier, and binds it to the IAM role that was used to invoke the Lambda. And then finally, the command uses kubectl exec and IAM authenticator under the hood to provide a shell into that pod. So we use the coach run command and give it the app name and the ecosystem or namespace, and it uses an open source tool similar to AWS Vault called AWS Octa to authenticate me with AWS. Shout out to the good folks over at Segment that maintain this tool. After I acknowledge receipt of my push notification on my 2FA device, it invokes the Lambda and the necessary pod and roles are created, and then I'm provided with a shell prompt inside the pod. So what are some things that we learned along the way? One of the main learnings from all of this is that engineers don't always need the access that they think they do. SRE teams have the ability to break glass and get into production systems if we ever need to. The likelihood that the rest of your engineers need that same ability is slim. Providing isolation here reduces some worry and allows folks to handle operations for themselves for the apps that they own. Another learning was that one-off tasks should be short-lived operations. We implemented a timeout for how long an isolated pod can be available to an engineer because we didn't want to have to think about engineers trying to reconnect to pods at all. They should be thought of as ephemeral. That means that tasks folks need to run shouldn't be super lengthy. Get a pod, do what you need to do, and get out. Anything more than that should probably be in code and reviewed in a pull request, and then queued up to be worked off by some background processor. And then a final learning was that Kubernetes Are Back has built-in privilege escalation protection. So we create these roles dynamically in the Lambda for you to exec into a pod. But in order to create a role, the cluster role used by the Lambda has to have the ability to create roles. And then furthermore, it also has to have the ability to create the roles with the specific verbs and resources that your new role has. Otherwise, you're not going to have the access that you think you have. That hung me up a little bit. I ran into that, and looking back, it's kind of common sense, but I just thought that was a good takeaway. So good job, Kubernetes, for doing that. And that's it. Thank you for being a great audience.
If anyone has any questions, we can take them now. Just raise your hand and I'll walk over to you.
Do you have any public code that's available for review or for? Do you have any public code, like open source code examples of using this?
Is this open source was the question, or any open source code? Gotcha. The question was, is there any public example of this, of what we built? No, not at this time.
Anyone else?
Hello? Can you hear me? Yeah. Did you try using System Manager?
The question was, did we try using Systems Manager?
Yep.
Like AWS Systems Manager? No, I didn't.
Okay.
I did not try that.
So we use System Manager to allow developers to get a shell access in using multi-factor authentication.
Interesting. Cool. And that works for Kubernetes also? Awesome. I got to look into that.
Anyone else? Raise your hand. Cool. Oh.
You folks have a blog post about this or a blog?
TBD.
I look forward to it.
We do have a blog. This is not on it. We have a blog on Medium. It's medium.com/Betterment. Yeah.
Thanks.